Okay, so in this class we're going to look at graphing the trig functions sine, cosine and tan, and I'm going to just start with sine. Okay, so we're going to look at graphing sine. And if I look here, if I think about some points, if I want to graph sine, I'm going to take my angle as my input and the sine of the angle as my output. So my x coordinate will be the angle, 0, 30, 45, 60, 90, etc. The y coordinate will be the sine of that, 0, a half, root 2 over 2, root 3 over 2, 1, etc. Okay, so I'm going to look at graphing that. I'm actually just going to graph it on GeoGebra. You can do it by hand, but it's a nice opportunity here to do a bit of practice work on GeoGebra. So I'm going to open up a GeoGebra file. There's my file ready to go. Okay, so there's a couple of things I need to do before I start to graph it. One thing, I want to just change my grid a little bit, so I'm only seeing the major grid lines. So I'm going to right click on the axis. I get this opportunity, this drop down menu, click on graphics, and I'm going to just go to the grid, and I'm going to just put in major grid lines. It's a little too fussy otherwise. Okay, the other thing I'm going to change is my x-axis, how that's graded. At the moment it's just going up in units. GeoGebra works by default in radians for angles, so if I'm finding sine of an angle, I've got to put it in radians. So one thing I'm going to change the input is to the angles. Remember, if I go back, we said the input, the x coordinates are going to be these values here, the degrees. Okay, so what I'm going to do is change the units on the x-axis to radians, and I'm going to have them going up. I want to include all special angles, so I want pi over 6 in there, I want pi over 4, I want pi over 3. These are all multiples of pi over 12. So when I go and right click again on my graphics, go to my graphics, and I'm going to go to my x-axis, and instead of going up in single units, I'm going to change the distance to pi. I'm just typing in pi for pi over 12, and again that / key is the over button, pi over 12. I'm just using this straight from my keyboard here. Okay, if you're doing it on your phone, you probably have another way to put in pi over 12. So I'm just putting that in there, and you can see we get all these things. All of these, that's 1 pi over 12, 2 pi over 12. So that there would be pi over 6, 3 pi over 12, or pi over 4, etc. I only wanted to go out as far as 2 pi. And again, if I look back at my table of values, I started at 0 and ended at 360, say, which is 13 pi over 6. But let's go out to 2 pi. So we'll go out to 2 pi here. Let me go back. So I'm going to what I'm doing here is pointing at my x-axis. This little finger comes up, and I'm going to hold down my shift key and kind of point to that till I get this arrow. That means I can kind of dilate that x-axis out there. And now I want to get a 2 pi out here. So that's good. So you can see special angles in here, pi over 6, pi over 3, pi over 2, 2 pi over 3, 5 pi over 6. In there, that's going to be pi over 4, right? These are going up in, if you like, in degrees. These will be going up in 15 degrees. So 15, 30, 45, 60, 75, 90. Special angles in there, pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, etc. Or in degrees, 30, 45, 60, skip, 90, skip, 120, 135, 150, skip, 180, etc. Okay, so that's the first thing. That's my x-axis sorted out. I'm happy with that. The next thing I'm going to look at is my y-axis. So my y-axis, again, I'm going to go and just point at it. I'm going to hold down my shift key here. You might be able to do this. I don't know how you do this on a phone. I think you've got to just stretch it out as you do most things on your phone, using your fingers. Okay, so there I'm going from, what I want to do is go from -1 to 1. So I'm just stretching this out so 1 is up high, -1 is down low. The other thing, I'm getting too many values in here. I'm just going to right click again here on this y-axis. Go to graphics. I'm going to go to my y-axis. I'm going to put distance of 0.5 in there. Just makes it a bit less fussy looking. Okay, so this is what we have so far. Okay, so this is what we have so far. These are all in radians. We could change those to degrees if you want. I'm going to just leave them here as radians. Remember, pi over 6, that's just 180 degrees divided by 6. Pi radians, 180 degrees, 180 degrees divided by 6. That's 30 degrees. Okay? The next thing I'm going to do is define a slider. A slider is a number that I can change, very quickly. It's a variable, and we slide the values on the variable. If we look up in here, the things that's changing all the time is the degrees, right? So that's what we call the independent variable. Sine depends on what angle I plug into it. So the slider I'm going to put in here, it says select position on this. I'm not sure what it'll say in yours, but when you choose it, it kind of automatically calls it 1, or A. You can call it whatever you want. Let's call it capital A for angle, right? And what I'm doing is I'm starting, remember, at 0, and we're going to finish at 2 pi. Okay, so 2 pi, just typing that in there. And I'm going up in increments. Well, I'm going to go up in increments of pi over 12. Pi over 12. Okay, that's what I'm going up in. Okay, which I think is 15 degrees, but remember, GeoGebra tends to deal in radians, okay? So I'm just going to hit OK, and there's that slider. Now what we see here, I can move that, fix objects. So I'm just going to look at this slider. What I can do with this slider is I can change that input value for A to all these numbers, starting at 0 and going up, and these are changing in increments of pi over 12. The next thing I'm going to do is go to my input bar and put in a point. Remember, a point has an x coordinate, then a comma, and then a y coordinate. My x coordinate is going to be whatever the angle is there that I've defined. At the moment it's 0 degrees. And my y coordinate, I said I want to be sine of that angle. I'm going to hit enter. Now what happens is, as I change that, at the moment, now unfortunately it puts in, instead of putting in pi over 12, it'll put in 0.26, and instead of putting in pi over 6, it's going to put in 0.52 over here. But what I want you to do is look at this point as it's moving around. It follows a particular path. So there's pi. So the input, when pi is the input, the output is 0. Again, refer back to the table of values. When pi is the input, the output here is 0 degrees. Or 0, I should say, not 0 degrees. Pi radians, the input, sine of pi radians is 0. So we're getting that pi comma 0 in there. GeoGebra is automatically rounding to 2 decimal places here as well. Pi, of course, is not equal to 3.14, but it's rounded to 2 decimal places. As you move out, you've got 7 pi over 6 there as my input. My output is negative 0.5, so you've got 7 pi over 6, which is approximately equal to that number there, comma, negative 0.5. And if I go forward here, 7 pi over 6, negative a half. You can see there's my input, there's my output. This is all just based on what we did in the previous class. Okay? So, and again, let me just turn that animation on so you can see that point moving across. And it follows a very particular path here. And I can trace that path to get a kind of idea of the shape of this thing. So let me put on a trace on this point. And I do that by just right-clicking. Actually, I'm just going to stop the animation. Right-click, animation off. I'm going to go to my point, right-click, show trace. Go to my slider, right-click, animation on. Now when I turn on the animation, it's going to kind of construct these values. So remember the input here, pi over 3, there's my output. That's actually root 3 over 2. Pi over 2 is the input is 1. 5 pi over 6 is the input, the output is positive a half. 5 pi over 3 is the input, the output is negative root 3 over 2. 11 pi over 6, for example, is the input. The output here is negative a half. And we have this very distinctive shape. And that's typical of the shape of the sine function. If I graph the sine function, which this is, we get something that follows that shape. So if I just go to my input bar now and type in sine of x, put in the letter x in there, you can see that fills in all the gaps for all angles, not just my special angles, all angles. So this is the graph of the sine function. This is the graph of the sine function. Okay. And one thing I'll note, that if I just zoom out from there, note all the thing it's getting, it looks like it's getting shorter. It's still going from -1 to 1. That shape just repeats itself over and over and over again. But the basic shape, and again I'm just going to put in just one kind of section of this. So I'm going to type in FUN. GeoGebra gives me this option for function start value, end value. So I'm going to choose that one. I'm going to type in the function is sine of x. In fact, I can just call it f because GeoGebra has called the function sine of x f already. So I can just type in f in there. I'm going to start at 0 and I'm going to end at 2 pi. If I just turn off my animation, right click on the slider, hit the animation key just because it's a bit distracting, and get rid of this thing here. There is one, what we call one period of that sine function. One period of that sine function. And after that, it just repeats itself over and over again, forever and ever and ever. Okay? Now, some important things to note. I'm just going to copy and paste this using my snipping tool here. I'm going to copy and paste this on here. Okay, so this is my sine curve. This is the graph of the sine function. Okay, so this is the graph of, I just put in the function. This is the graph of f of x equals sine of x. Okay, that's what it looks like. And there are some important quantities you need to know when you're discussing the sine function. And I'll just make a list of what those are called. The first quantity you need to know is called the period of the function. You gotta know what that is. You also have to know what's called the range of the function. You also have to know what's called the amplitude of the function. You also have to know the equation of what's called the horizontal midway line. Okay, so these are all important things that you have to be able to read. Okay? So the period of the function, well, the period of the function is how often it repeats itself. It starts here, it turns around, it goes, and then it completes one full period in there, and then it repeats itself again. So one full period goes from 0 all the way out here to that value there, which is 2 pi. So the period of this function is actually 2 pi. I have to use this because my pen is not working at the moment, so period of the function is 2 pi. So that's the period. The range just tells me what's the lowest value, what's the highest value, and it kind of puts those in a bracket. Number one, I'm using square brackets. Why? Because the lowest value is included in the function and the highest value is also included. So this goes from the lowest value here, the lowest output here is -1. And it goes all the way up to the highest output along this line where the output value is 1. So the range of this trigonometric function is -1 to 1. The period, remember, was equal to 2 pi. Period, one full period, and then it just repeats itself forever and ever. The amplitude, well, we'll talk maybe about the horizontal midway line first. It's a horizontal line exactly halfway up the curve. You can see it's the x-axis. The horizontal midway line here is the x-axis. But the equation of the x-axis, well, what have all points on the x-axis got in common? What they all have in common is that the y-coordinate is equal to 0. So that's the equation of the horizontal midway line. The y-coordinate is always equal to 0 on the horizontal midway line. The amplitude, well, the amplitude tells me how high the function is above the midway line. And that's just 1 unit above the midway line. Notice the amplitude is just half the distance between the lowest and the highest value in the range. So the amplitude of that function is equal to 1. Okay, so what you have to be able to do is convert, your values for sine into a sine graph like that, or a sine curve. And you have to be able to comment on different, quantities within that sine curve. And these are very important quantities: the period, the range, and the amplitude. You got to know those words: the horizontal midway line, a horizontal line halfway up the curve. Okay, period 2 pi. Every 2 pi units we have this repeating shape. The range -1 to 1, lowest value of -1, highest value of 1. Those are output values. The amplitude is 1 because it's 1 unit above the midway line. The midway line has all points in the midway line have y-coordinates of 0. So the midway line has equation y equals 0. And that is how you graph the sine function. By the way, every curve that looks like this is said to be sinusoidal. Sorry, I've spelled that wrong. Sinusoidal. Spelling issues coming up. I think that's how you spell it. Sinusoidal. This is a sinusoidal curve because it looks like the sine function. We're going to graph the cosine function next, which is also sinusoidal. It just means it looks like the sine function. Okay, it looks like a sine wave. This is often called a sine wave. Okay, so you got to practice drawing that. Practice it by hand. Practice it using GeoGebra. Get used to it. Okay. Next we look at graphing the cosine curve.